DCG students, welcome to this perspective projection lesson, an example from the 2013 higher level exam paper. Let's take a look at this now. So we have this question. The Egyptian pyramids shown in the 3D graphic below are considered to be architectural masterpieces. They are square based and were built in precision in terms of alignment, geometrical shape and proportion. Shows the plan elevation of a square based pyramid with an intersecting triangular structure. Entrance, and now it says draw the given plan and elevation and construct perspective drawing of structure given the following. Spectator point is 8 meters from corner A. The picture plane is touching the corner A. The horizon line is 5 meters above the ground line. And note, use an auxiliary vanishing point to locate the sloping edges of the entrance. Now there's a scale on the question. 1 is to 100, so 8 meters would transfer to 80 millimeters and 5 meters to 50 millimeters, and the auxiliary vanishing point is the new part we are dealing with today, which was not present in the previous example. Let's get to it.
Okay, so having reviewed the question, alright, what I have done is I have pre-drawn my elevation and plan here, and I've positioned both of those up in the very top left hand corner of my page, and my page is in the portrait direction, okay, orientation. Now, just to bear in mind, when you draw this front triangular piece, okay, you're given the measurements for it, fine. But there is one point in the plan view that you must transfer in order to find it. Transfer it across to the edge, drop it down to hit the line here, and bring it across to meet the line coming straight down. That will locate that back point, the intersection between the front entrance to this pyramid structure and the actual surface of the pyramid itself. Okay, so very important to bear that in mind. Now, where do we want to go from here? Well, the first thing, like the previous questions, is we want to find the picture plane. Okay, so in order to find the picture plane, we must find our spectator now. We're doing this a little bit in reverse from the previous day. So, in the question it said that the spectator is located 60 degrees from corner A at a distance of 8 meters. Now, in the scale of our question, okay, and the scale being 1 is to 100, that 8 meters is actually 80 millimeters. So, when I transfer that on here, what I'm going to do is I'm lightly going to draw a line at 60 degrees from corner A, okay? So, very lightly first, from corner A, 60 degrees, sorry, use the pencil instead there, draw a light line. Okay, now measure 80 millimeters back on that line from corner A. So, I'm measuring 80 millimeters, like so. Lovely. Now, so that's my point S located there. Okay, and what I'll do is I will just rub out the extra bit that ran on there. Okay, and we'll change the colour of that line so it's nice and visible to you guys at home. Okay, I think I'll use the pink one for that. So I'll just join it back there. So 60 degrees, 80 millimeters long. Now, next thing we want to do is find a picture plane. So, in order to do that, what we're going to do is we are going to go from the furthest corner here in the plan view back to point S with a line, like so, and we're going to repeat that from the furthest corner over here back to S, like so. Okay, so I have these two lines now, so what I want to do there is I want to bisect the angle that they have created. So I'll take my compass. Now I'll use the small compass for this so I can put the colour in and show you a little clearer, because I want to make sure that we're all okay with what we're doing here. Any distance on the compass there. Okay, and we're going to swing an arc. Okay, now that arc intersects the line here and the line here, 2 intersection points. Take the compass. Key thing here is that you keep the same distance on the compass for both arcs to bisect the angle. Alright, now that point there, we will be able to draw our bisector through that point. So we'll use a different colour for that. We can take a little bit of green and we'll run with that. So from S now, through the bisector point to create the bisector line. Okay, now I might put that in as a dashed line. It's not hidden detail or anything like that, but just so we can differentiate between that line and the other lines that are there. And I'm just going to roughly draw it up as far as there. Okay, now what I want to do is I want to draw the picture plane at a right angle to that line. So in order for me to do so, here's the quickest way. Line up the inside line of your set square with the line, like so, and line up your outside point with the top edge of your set square. So the inside there is in line with the bisector. The top edge is passing through point A. That gives me a right angled line. Okay, now I'm going to draw that line like so. And I'll draw it on back in this direction as well. Okay, now, so that's my picture plane. Okay, and that picture plane is at a right angle to the bisector line, okay? And it passes through point A, alright, as stipulated. Now, what we want to do here now is we want to draw our vanishing line from point S, and we'll use a different colour here again. I think we'll go with the light blue again. So I'm going to draw my vanishing line from point S up to meet the picture plane, okay, like so. That line is drawn at the same angle as the side of the object, okay, they are parallel. And likewise, we're going to take this side as a straight line, okay, horizontal basically, and we're going to draw from point S over, we're going to draw our vanishing line. And you can see there, I need to bring my picture plane just a wee bit further, just so that they intersect, like so, okay. Now, so, and I'll write in vanishing line just as VL, okay, VL. And these 2 points here now, they are going to be the points now that are going to inform our vanishing points, okay? So we can actually call them VP1, VP2, but these are the vanishing points in a plan view position, okay? And we want to get them in their elevation position now in a few moments. So what we're going to do is we are going to project out our vanishing points now with our vanishing lines at a right angle to the picture plane. So I'm going to move this fella over here, and I'm going to get my set square, and again I'm going to use my little line technique here. I'm going to line up the inside of the set square with the picture plane like so, and I'm going to line up the outside line with VP2 in this case. I'm going to draw that line on down there. Don't worry about the length of it, just draw it on down. Okay, I'm going to adjust my visualizer now so that we can get in view of the rest of it there. Okay, we'll kind of forget about the elevation for the moment. We'll jump back up there in a few moments when we need to. Okay, so apologies about the moving around. I just want to get the full plan view in there if I can. Yeah, okay. And likewise here now, I'm going to go from, again, line up with the outside, line up the inside line of the set square there. Of course you could use a protractor as well if you wanted to, or you could use sliding set squares from the line you created on the other side, and just draw that on. Again, don't worry about the length of it. Now, what we want to do is down here, we want to set up our ground line. And our ground line was, in the previous examples, the line that we set up just past the furthest edge of our plan view. In this case, what we have to allow for is the information given to us about the horizon line, okay? And we got to think about, well, the size of the structure and so on. But for the horizon line, the information given to us was that the horizon line is 5 meters above the ground line, okay? Now, 5 meters at a scale of 1 is to 100 is 50 millimeters, okay? So the minimum, and I'll use S as a reference point here now, okay? The minimum I would come down here to set up my ground line is 50 millimeters. The very, very minimum. Alright? And if you have the space, position it down as far as you can, really. Okay? What I'm going to do is I'm going to position it down at least 90 millimeters, okay, from S. Now, if you want, and don't project S down there at the moment, okay, you can just roughly make a dot from S, just mark 90. Okay, it doesn't have to be perfect, but what I'm going to do there now is line in my set square up, inside line in line with the vanishing line, and the outside line in line with the point I marked just a moment ago. I'm going to draw my ground line, okay, and I'll draw that ground line heavy, and I'll put the note in there, ground line. Now, so I have the ground line here, that's like our XY line. Now I'm going to apply the measurement for the horizon line, which was 50 millimeters. So, 50 mil above the ground line here, on the vanishing line that I have, I am going to mark my 50, like so. And I'm going to do the same down on the bottom side. I'll have to adjust my, so that you can see here, 50 again, from the ground line up on that vanishing line, and we mark it like so. Okay, so what we have now in the elevation, because this is our elevation, VP1 in its position in elevation, and VP2. Okay, and we're going to join them with a very light line. We'll join them with a very light blue line there. Okay, like so. That's the horizon line. Okay, both vanishing points are contained on the horizon line. Well, in effect, the vanishing points, they create the horizon line too. So they're both equally important. And I'll just put in the acronyms there. So I'll just HL, the abbreviations, horizon line, and GL for ground line. And we VL here for vanishing line, and that's the vanishing lines coming down here. So we'll just write VL beside them as well. Now you don't have to do this, but I'm just trying to create I suppose a better understanding of the parts that are involved. Now, so from there, what do we need to do? Well, we need to start taking projection lines from our plan view back to point S. Okay, but before I do that, there's one step, and I recommend you do it at this stage. Identify the point that is on your picture plane in the plan view. So this is the plan view. So what we have here is we have our picture plane, and it passes through point A. Okay, and if we looked at point A in the elevation, we will see that point A is here, alright, and it's on the ground, and there's no height associated with it. Okay, so what we need to do there now is we just need to position point A, alright, and we will do that. So point A, given that it's already on the picture plane, we can project it down at a right angle off the picture plane. So doing that, we can use our sliding set squares, or we can line it up like we have been doing previously inside of the set square and so on. But for variety, I will use the sliding set square method, and I will take that point A down, and again I'll use I think I'll use the light. I'll use the pink. No, I won't use the pink. I'll use the green for this one. Okay, so bring that on down like so, and bring it down to the ground line, alright, because that's where point A exists. Okay, and what I can do there, using my blue pen, I can connect a line from VP1 to A, and these are all vanishing lines now. Okay, and VP2 to A. Okay, and now the footprint of our pyramid is going to become more evident as a result. the next 2 points I want to take down, if I was to label the other corners of the actual plan view. So if I was to label this point B, label that C, we label that D, and we label the top point there O. Okay? So we'll just focus on the yellow structure, don't worry about the orange one at the moment. We'll leave that for a little while. So, point B, we already have a line coming back to point S. Where it crosses the picture plane, that's the point we're interested in bringing down. Okay? So I'm going to write that now as point B there. Point D is brought back to S, okay, as we originally did. Where that point crosses the picture plane, that's point D. Okay? And then we have point C, which I need to bring back. So I'll take point C, I'll bring it back to point S like so. And where point C crosses the picture plane, well, that's point C. And then point O. Where point O crosses the picture plane, we'll bring point O back to S, and we'll get the point right here. So that's O. Now, I have those points there, D, C, O and B, brought back to point S. That's them on the picture plane. So, now, let's just bring them down. Okay, don't worry about anything else. Let's just go to our line there for A, that one there, and we'll line up our set square there, and we'll do our sliding set squares to bring those points down. And I'm just going to bring them all the way down to hit the ground line. When you're doing these, just make them very light construction lines, okay? Now we could go into the thing of just projecting them exactly to where they belong, but I think we get into a whole area of uncertainty then, because as the drawings get more complex, the more points and lines you'll have, and I think moving forward you should always have a template with how you want to find your points. So if I was thinking about joining A to D, which I won't directly because I have this orange bit which I'm going to add in a minute, I would be thinking that A to D would be on this line here. So what I'll do there is I will locate point D, but I'm not going to create a heavy line. Here's the point D being brought down. It's going to be on the vanishing line from A to VP1 along here, and what we'll do is we'll mark that point now. So there's D right there. Okay? Now for point B, B comes down and it intersects the vanishing line going from A to VP2. So there we go. We have that line, B. Okay, and you see how much shorter it is than the actual one. It's, I mean, probably about 2/5 of the length. And then I'm going to go, well, where's point C? Well, here's the projection line for C coming down, but I don't know where to stop it. But it's in line with B and D, isn't it? So what we'll do there is we'll connect point D back to VP2, and we'll connect point B back to VP1. Now if these are lined up correctly, they should both intersect perfectly on the line for C coming down, which is right there, and they do. They cross over perfectly right there, and that's point C, and that's out the back. Now I'm not going to have heavy any of those at the moment, because what I want to figure out now is this orange bit here, the points that are on the ground at least. So I know that there are a couple of points here on the ground. If we have a look, so we have this point, we'll call that point 1. This one here we'll call it point 2. This point here we'll call it point 3. This point here we'll call it point 4. Okay? So we have 4 points on the ground there. There they are in the elevation. We'll have 2 in front of 1, and we'll have 3 in front of 4. Okay? Now, how do we locate them? That's what we're going to do now. So I'm going to take my visualizer back down here, and we'll just focus on those points 1, 2, 3 and 4. Well, firstly, they need to be brought back to point S. So I'm going to line up point 2 with S, like so. Okay, And where point 2 crosses the picture plane, very close to point D, I'm going to mark it 2. Okay, and I would say that you should always do that one line at a time. Very easy to get confused here in the long run. Then I would do point 1, and again mark point 1, and then I'll go to point 3, like so, point 3. And then finally then I will do point 4. Point 4. Okay, back to S. And point 4 intersects the picture plane right here. Point 4. I'll just write that in there. Okay? Now, so I have my points there, and you can see they're kind of gathering up on that line now, but I have them labelled. I'm fairly certain of what to bring. So I'm going to get my sliding set squares now. I'm going to set it off that original line again, the line coming down from point A, okay, like so, and we will bring down point 4, and again just drop them down there, okay, all the way down, point 4, okay, point 3, point 3, point 1, and then point 2. There. Lovely. So I have all those points brought down now. Now I want to figure out, well, where's what? Well, point 1 is hitting out here, and it travels down to intersect the line for A and D. So I'll follow line 1 down. Here's where it intersects. So there is my point 1. Okay. Point 2, I don't have that yet at the moment, so here's the line for 2. How do I find it? Well, it's coming from point 1, isn't it? So what we do is we line up VP2 with point 1, and we extend out to the line for 2. And you'll see there now, I have the point for 2. Right there. Now, point 4, we'll go there first. So here's point 4, brought back to S, there's where it crosses the picture plane, bring it down, and as I can read it all the way down, point 4 is right here. Okay? So, we'll mark that point 4. And to find point 3, we'll use the same trick we used the last time. From VP2, we go to point 4 and extend it on out to meet the line coming down from point 3. Which is right here. Okay? So there's point 3. Now, of course, I could have taken a vanishing point from VP1 through point 2 and on to the line 3, and that would have given me 3 there as well. Okay? But look, what we want to do now is we want to find the top point here, point O. Now, point O, which is just here, alright, has a height in the elevation of 80. Now, we cannot mark out directly 80 millimeters on that line coming down for O. We can't do that. And what I'm going to do is I'm going to introduce you to a new method here. This is what I call the slide method. So imagine we have, say, like a point on the picture plane. When we have that situation, we can actually take the true measurement for that point. Now, I could do O a different way than what I'm going to show you now, but I want to show you this one because I think it's more transferable. What we're going to do is we're actually going to transfer that point O on to the picture plane. So, line up point O in plan, alright, and we're actually going to slide it. Imagine if we were taking this whole view and sliding it down to the picture plane till point O was intersecting that picture plane line. That's essentially what I want you to visualize in your head. So imagine sliding point O all, and I'll use a dotted broken line in red so you can see. Okay? Extend that line all the way. I'll do it, that line, so you can see it. Okay? So take point O, slide it on. Now, we're going to call this O1, alright, because I don't want you to confuse it with O where it actually is when we get the elevation itself. What we're going to do with this O1 line, okay, is we are going to project that down now at the same angle as the rest of the lines. So, again, I'm going to line up with that line for A. I'm going to slide it over to O1, and I'm going to bring that line O1 down. I'll bring it down as just a solid red line, like so. Okay? Now, I have that line brought down. It's at a right angle there. And what I'm going to do on this line, because now we have virtually, if you want to call it, moved the point O down onto the picture plane, we can actually mark a true height on this line now. So the true height for O in the original drawing is 80. So from the ground line, I mark up 80 millimeters. If you want me to use the set square in reverse, here we go. 0 on the ground line, mark up to 80 millimeters, like so. Now, mark the point and then mark O1. I then take a line from O1 back to the furthest vanishing point. So in this case, I am going to take O1 back to VP2 because it's further away. Like so. Alright? So you can see that red line now going back there. What do we want to do with that? Where that red line intersects the point O that's to be brought down, okay, and we have it brought. So there's O on the picture plane, the original O, after it was brought to point S. Where that line intersects that red line I've just drawn now, that is my top point. So there we go. That there is the real point O found. Okay? So we slid O forward onto the picture plane. We brought it down. We took the true height for O because now technically it's on the picture plane. We mark 80 millimeters up. That's the true height. Bring it back to the furthest vanishing point, or the one most relevant to the point. And where it intersects the projection line for O coming down, well, that's our point. Apologies there about the light on my visualizer. So there's point O found. Now what I can do is I can draw in most of the structure as follows. Okay, so I'm going to heavy in my line A to B on the ground, like so. That line P to C, that's out at the back. You could leave it out, but sure, we'll draw it in as a hidden detail line. Likewise, the line C to D, that's going to be a hidden detail line. The line, we do have another bit to draw up in the front here, so I'm not going to heavy in that bit. I will heavy in here, and I will heavy this bit here. Well, that will be a broken line there as well. I'm just leaving this bit for the moment because I want to complete out the view, finding this point, and I want to use a different method for that. And there, and we go heavy from there to there, and then what we'll do is we'll go up to point O, from A to O. Nice line, clear line. We'll go from B to O. We'll go from C to O. What we'll do there is that'll be a dashed line at the back, as we cannot directly see that. And then we'll go from D to O. Okay, so now I just have this little front bit to do, so you can see the pyramid, the way it is formed. Now, it says in the question, when we jump back into it, it says note, use an auxiliary vanishing point to locate the sloping edges of the entrance. So, in order for us to do that, alright, what we have to do is we have to look at the angle that is contained in the original question. So the angle for that front surface is 40 degrees. Now, what we're going to do is we're going to use that 40 degrees to help us find what's called an auxiliary vanishing point. That means auxiliary means extra. So we have VP1, we have VP2, and then what we want to find is VP3. Okay? And what's important here is that I'm noting the angle here in the elevation, which is 40 degrees. Alright, and what I'm going to do is I'm going to go to the plan view, and I'm going to go to point S, and depending on whether the surface you're trying to find is facing the vanishing line here or the vanishing line here, we use either one of those lines as our guideline for finding our vanishing point, our extra vanishing point. So as you can see, that this surface here that we're trying to form using auxiliary vanishing point is facing the vanishing point here, and I'll distinguish that as vanishing line 1, and this one is vanishing line 2. Okay, so vanishing line 1, what we do, this is what we do to find the auxiliary vanishing point, is we take our protractor now. The angle in the question was 40 degrees. So turn your protractor. Well, you can do it this way. I'm just going to do it down into this open space here, lads, because it'll be a little bit clearer. I don't want to be drawn in on top of everything. So I'm going to point my protractor down this way, lining it up, centering it on point S, and lining up the 180 degree line on the vanishing line 1, like so. Now what I'm going to do is I'm going to take my, we'll go for a green marker here, and we're going to mark a 40 degree point. Okay, so I've marked 40 degrees. That's the angle of this surface, the orange surface in the elevation. Okay, so 40 degrees, and what I'm going to do now is from S, I just want to double check that that's 40 degrees. Yes, it is. Happy with that. From S, I'm going to draw a line now through that point, and I'm going to extend it on. Okay, so you can see that line I've drawn now. Okay, we'll put it 40 degrees, and we'll just indicate there that the angle is contained between vanishing line 1, okay, and the line we just drew. Here's the thing, what we want to do now is from VP1 we want to extend the line down that's at a right angle to the vanishing line down to hit it. So in this case I'm going to use my protractor because I'm very tight to the edge of the page. I'm going to put my protractor on VP1. I'm going to line it up on the VL1 line. Okay, we're okay with that. And what I'm going to do is from there I'm going to mark 90 degrees. Okay, now I'm going to extend from VP1 down through that point I've just marked on to hit the 40 degree line. Okay, so we might just use a set of arrows to indicate this, and to indicate that this one travelled down like so. And what that gives me, okay, we're going to call this distance, we'll call this VP X VP or Aux VP. A U X VP. Now, we're not going to use it from that position. What we do is we go, right, we're taking the length of this line, okay, from VP1 to Aux VP. We're taking that length and we are now going to position it above VP1 here in our auxiliary elevation. Remember, this is an elevation. So the best way to do that, I think, is to get your compass. Okay, I'll write down a distance on this here. Okay, so a distance. So from VP1 all the way down to the auxiliary vanishing point. So let's have a look at that. Point in there, stretch it down. Here we go. There's the distance I'm taking. And why am I putting it on top of the VP1? Well, sure, in the plan view, isn't it there on top of the VP1? Okay? So we position it right here. Make your arc. Okay? Mark your point. Okay? And we'll call it again Aux VP. That's it now in its usable position. Okay? It's directly above the vanishing point 1 line that's heading back towards the picture plane. Okay? Now, so that's the distance established. Okay? And I just make that a bit clearer there. So we'll put it inside these two lines so that we know now that when we look back on this that it's this distance here. Well, actually, I'll write it this way: D-I-S-T-A-N-C-E. So when you look back, you'll know that that distance, it came from here. I'm now going to draw a line, and I think I'll use a different colour once again here. I think I might use my, well, you know what, we'll use our green. Line up your auxiliary VP with the point 3 there. Okay. Now, this will give us a line. It's a vanishing line, okay? So from point 3 going back to the auxiliary vanishing point. However, what I'm really looking for here is I'm looking for the point that's here in the plan view. So I'm going to call that there, that particular point. I'm going to call that point 5. And I'm going to call this one behind it point 6. Okay? And if we were in the elevation, we would see points 5 and 6 here. 5 in front and 6 behind. So I'll bring that forward again. And what I'm going to do, before I find anything down below, is I have to bring both points 5 and 6 in the plan view back to point S, the spectator. Like so. As I bring the first one back, note where it crosses the picture plane. 5. Line up point 6 with S. Okay. And note where point 6 passes through the picture plane. And it virtually lines up with point 3. So that's a coincidence. It lines up with point 3. So we can assume that the line for 3 also is representing point 6. Now, point 5, we need to bring that one down, because it didn't line up accidentally with anything. So I again go to my line A, and I'm always consistent when I always use the same line to remeasure from when I'm doing my sliding set squares, because we want it, if we're making a mistake, we want it to be consistent, you know, because we'll be accurate with that. So I'm going to take point 5 down now, all the way down to meet the ground line. Now, where point 5 intersects the vanishing line for point 3, that is our point 5. Okay? And you might go, well, why is that? Why don't we have to find point 5 with its own point 5 line somewhere down here? Well, the beauty of the vanishing point is it saves us doing any of that, because this vanishing line represents a surface. Okay? So that surface we're working now at the moment is 40 degrees. We calculated the auxiliary vanishing point for that 40 degree surface. And so therefore, if I draw a line on that surface, it will be represented. The point on it will be represented. So that's point 5 here. Okay, and what I do there with point 5 is I join it back to point 2, like so, and to point 3. We just heavy it in like so. Now, you might be able to tell a huge amount of difference in the colour there, but what we have then, we can complete out the projections on the bottom. That'll be heavy, and then we'll have a little bit of a broken line in there, very small bit. And now we want to find point 6. Now, given that we have point 5, all we have to do there is join point 5 back to the vanishing point 2. So I line up like so and draw back, and I have the vanishing line going back. It kind of lines up with that hidden detail line at the back. What I do then is I track down my line for point 6 from the picture plane to intersect that line, and there it is right there. Okay, and what I can do then is I can join from point 4 to 6, 4 to 6, right here. And then I can also heavy the line connecting 5 and 6. And therefore I now have the drawing technically completed. Okay, And to complete it out here for you guys, so we can differentiate between the surfaces, I'll add a little bit of colour. Okay, just so we can see kind of what's what. And like so. Okay, and again, look, you don't have to waste time colouring if you don't want to. I think for the few minutes that it takes, that it gives a nice effect. Okay, because these drawings, when you get into the higher level ones, and they're a little more, what would you say, involve more points and more lines, they can tend to look a bit on the heavy side and kind of condensed and so on. So there we go, that's the orange block. And a tip when you're rendering here, try and render in the direction of your vanishing points, okay? Unless you have a vertical surface, like here. And I'll just do vertically. Okay? And there we go. That is our auxiliary elevation. Auxiliary elevation.
Okay, so that's the question done. You can see the solution there, the hand-drawn one, the picture, and also the electronically generated one. And of course, look back over if you need to.